Okay, so we current Katie's netball player claims she stands at distance 2 metres from the goalpost with a probability of at least 70% that she will score a goal. Lloyd, her brother, challenged her to prove this by throwing 6 sets of 10 from this distance, and the results are in the table. Then Lloyd has made a cumulative table to show the cumulative number of goals to calculate the relative frequencies. So after 10 throws, scored 5 goals, so the relative frequency is 5 out of 10. After 20 throws, then 5 goals in the first lot of 10, 7 in the second lot of 10, so that's 12 goals out of the first 20. So the probability is 12 out of 20, which cancels down to 6 out of 10, which gives me 0.6. For the third lot of 10, there's 6 goals, so that's from the 30, there'll be 5 and 7 and 6, that'll be 18 out of 30, and that'll cancel down, 18 out of 30 will cancel down to 6 out of 10, which is 0.6. So after 40, after the fourth block, there's another 10 there, so that's going to be 5 and 7 is 12, and 6 is 18, and 10 is 28. So the relative frequency then will be 28 out of 40, so I need to change that now to a decimal, so 28 out of 40. To get that out of 10, I divide that by 4, so I do the same to that, to divide by 4, so that gives me 7 out of 10, which is 0.7. After 50, right, there's another 8 goals scored, so there'll be another 8 goals on top of the 28, or you can add up all those numbers, and that'll give me 36, so the relative frequency is 36 out of 50, and then 36 out of 50, I can scale this up out of 100 first of all, times by 2, same there, times by 2, so same as 72 out of 100, and move the point 2 places to the left, so that's 0.72. And finally, after 6 of throws, there's an extra 9, so extra 9, 36 and 9 is 45, so that's 45 out of 60. So I need to change that to a decimal, 45 out of 60. And then let's to scale it up, let's bring it down, let's cancel it down. 5 goes into both, 5 into 45 goes 9, 5 into 60 goes 12. Still no scale, let's cancel again, both in the 3 times table. 3 into 9 goes 3, 3 into 12 goes 4, so 3 quarters is 0.75. Okay, so draw this graph then. So after 10 throws, that's 0.5. So 0.5 is halfway between 0.4 and 0.6. 1, 2, 3, 4, 5 squares there. There's 0.5. So after 10, 0.5. After 20, it's 0.6. After 30 is 0.6. 40 is 0.7, so 0.7 is halfway between 0.6 and 0.8. So 40, just bring that across there. 40. After 50 is 0.72, so that's at 0.7, and these are going up in 0.02s, 0.7, 0.72, 0.74, 0.76, 0.78, 0.8, so it's 1 square above the 0.7. And 60 is 0.75, so 0.7, 0.72, 0.74, 0.75. So that's the relative frequency graph for that. It says, is Katie correct to claim that probably scores a goal from the distance is at least right? The most reliable answer is the last one, because she's carried it out 60 times, and that probability is 0.75. So yes, because the best estimate for the probability of scoring a goal is the last one that's been carried out the most number of times, which is 0.75, which is 75%, which is greater than 70%. Okay, so the last point you plot is always your best estimate for that relative frequency.